Creepy Crawly Jew, or Betelgeuse, a red Goliath star, is one of the most captivating items in our universe. Assuming it were positioned where our Sun is, its immense size would extend to the orbit of Jupiter. This enormous star is highly temperamental and near the brink of exploding, making it one of the most significant sources of radio energy in the universe. Betelgeuse generates more energy than a billion suns. Its vast size and instability have fascinated astronomers for a long time. Located in the constellation Orion, Betelgeuse has recently exhibited unusual behavior, such as significant dimming and violent vibrations, which have led to theories that it might soon detonate in a cosmic explosion. However, there is also the possibility that we might witness an even more terrifying event: the star collapsing into itself. This potential collapse could have profound implications for the future of the universe. With a size 950 times greater than our Sun, Betelgeuse is one of the largest stars known. Despite its grandeur, its enormous size means it has a limited life expectancy, essentially making it a ticking time bomb. Located about 650 light-years away, Betelgeuse captivates stargazers who marvel at its splendor and try to uncover the secrets hidden within its fiery depths. Although only about 33% of its brilliant energy is apparent to us, if we could see its full brilliance, it would outshine even Sirius, the most luminous star in our night sky. Imagine a star whose reach extends multiple times beyond that of our Sun, reaching nearly to Jupiter. In this vast domain, Earth, Mars, Mercury, and Venus would be overwhelmed by Betelgeuse's vast presence. Every day, Betelgeuse sheds a solar mass, casting off its celestial remnants in a grand display of cosmic drama. A cloud 150 times larger than the star itself envelopes Betelgeuse, covering it in an ethereal darkness that dazzles our view. This cloud extends 30 galactic units, inviting us into a grand cosmic dance and enticing us to uncover its mysteries. As the universe continues to evolve, Betelgeuse's looming cosmic explosion remains a symbol of both scientific interest and a measurable spectacle. This colossal star, with its eccentric behavior, offers a unique opportunity for scientists to study stellar evolution continuously. The cosmic explosion event is anticipated to be a crucial moment in Betelgeuse's life cycle, potentially offering insights into the final stages of massive star evolution and the processes that drive such explosive events. When a red supergiant like Betelgeuse exhausts its nuclear fuel, the core contracts under gravity, leading to an intense buildup of pressure and temperature. This process can trigger a supernova explosion, propelling the star's outer layers into space and leaving behind a dense remnant. Depending on the mass of the remaining core, this remnant could become a neutron star or, if massive enough, collapse further to form a black hole. Thus, Betelgeuse's cosmic explosion won't just be a spectacle for astronomers, but also a critical event for understanding the mechanics of such explosions. Supernovae are essential to the formation of elements heavier than iron, which are scattered into space and contribute to the interstellar material that forms new stars, planets, and even life. The remnants of Betelgeuse's explosion will enrich the interstellar medium with these elements, continuing the cycle of stellar birth and death that shapes the universe. In addition to its impact on astronomy, Betelgeuse's cosmic explosion will provide a natural laboratory for studying the effects of such explosions on their surroundings. The shock waves from the explosion will interact with the surrounding interstellar medium, creating a pulsar wind nebula or a supernova remnant, depending on the explosion's characteristics. These interactions can trigger the formation of new stars and planetary systems within the nebula, demonstrating the intricate relationship between stellar death and rebirth. Observing Betelgeuse's evolution leading up to its explosion will offer valuable data on the final stages of a star's life. Scientists will monitor changes in the star's luminosity, spectral lines, and other properties to better understand the processes occurring just before an explosion. Such observations are crucial for refining models of stellar evolution and supernova mechanics. The data collected could also help explain variations in supernovae observed in different parts of the universe. The impact of Betelgeuse's cosmic explosion on Earth will be negligible given the star's distance from our planet. However, the event will likely have scientific and cultural significance for astronomers. It represents a rare opportunity to witness a supernova in a relatively nearby star system, providing a clearer view of the explosion's mechanics and aftermath. For the public, it will be a magnificent celestial event, sparking interest in astronomy and space science. Social reactions to cosmic events have historically ranged from awe to myth-making. As Betelgeuse approaches its end, its inevitable explosion will likely inspire a new wave of cultural and artistic expressions, from literature to visual arts. The dramatic imagery of a dying star and its explosive finale will capture the imagination of people worldwide, continuing a tradition of celestial events shaping human creativity and thought. Regarding technological advancements, observing Betelgeuse's cosmic explosion will push the boundaries of current astronomical instruments and techniques. Astronomers are likely to deploy advanced telescopes and space observatories to monitor the event, capturing detailed images and spectra of the explosion. The data gathered will enhance our understanding of stellar processes and could lead to improvements in observational techniques and technology. The cosmic explosion of Betelgeuse will also serve as a case study for comparing the behaviors of different types of supernovae. By analyzing the characteristics of Betelgeuse's explosion and comparing them with other supernovae, researchers can gain insights into the factors influencing the outcomes of such explosions. This comparative study will help refine theoretical models and improve predictions of supernova properties, ultimately enhancing our understanding of the life cycle of massive stars. Additionally, Betelgeuse's impending explosion will likely become a reference point for future studies of stellar death and supernova phenomena. As one of the most anticipated supernovae, its observation will provide a benchmark for future research and guide investigations into the final stages of stellar evolution. The information collected from this event will be invaluable for future generations of astronomers and astrophysicists. The study of Betelgeuse and its impending explosion highlights the interconnectedness of the universe. The life cycle of stars, including their explosive deaths, plays a crucial role in shaping the universe. By understanding these processes, we gain insights into the formation and evolution of galaxies, the distribution of elements, and the potential for life elsewhere in the universe. As we delve into the core of Betelgeuse's creation, we find that the chemistry of hydrogen fusion ignites and produces helium, triggering a massive explosion. Over time, the star's hydrogen fuel decreases, leading to a stellar transformation where helium combines with carbon, emitting brilliance that spills across the universe. As neon merges with iron, a dramatic change occurs. The star's gravity, unbalanced by the lack of energy release, initiates an inevitable collapse, driving Betelgeuse toward a fate that is both spectacular and catastrophic: a supernova explosion. In the realm of celestial phenomena, supernovae reign supreme, and Betelgeuse will be no exception. With the energy of 10 billion suns, this colossal celestial body will unleash a force that reverberates throughout the universe, leaving us in awe of its incredible power. Throughout the ages, stars undergo a mesmerizing transformation, progressing from the vibrant blues of youth to the blazing reds of maturity. During the 2nd century BC, Chinese astronomers observed Betelgeuse's distinct yellow tint, setting it apart from the celestial tapestry. As centuries passed, Roman astronomer Timon recorded Betelgeuse as having an orange or reddish appearance. This characteristic continues to captivate our attention today. The consistent color across different epochs, including medieval observers in the Middle East, contributes to the intrigue surrounding Betelgeuse. In 2019, Betelgeuse astonished researchers by unexpectedly dimming in brightness. Initially, it was thought that a massive dust storm on the star's surface obscured our view. However, the origin of this cloud remains unclear. Some researchers hypothesize that a large object, such as a planet, could have disrupted the star's surface or even been swallowed by it. Recently, Betelgeuse has become nearly twice as bright as its usual luminosity, a surprising event since stars typically become dimmer with age. Researchers are uncertain about the cause of this sudden increase in brightness, although they understand that star brightness can vary due to multiple factors. For example, some stars undergo cycles of bright and faint phases, similar to the star reflect known for its regular changes in brightness. Deep within Betelgeuse, a seismic shift has occurred. The explosion of expelled material into space has created a magnificent dust cloud, obscuring a significant portion of Betelgeuse's brilliance. This has transformed it from a dazzling guide to a dimmer light in the night sky. Once among the 10 most brilliant stars, Betelgeuse now ranks lower than the 20th most brilliant. This dramatic change in brightness has intrigued researchers and astronomers. Some theories suggest that massive sunspots or dust clouds might be responsible, while others consider the possibility of cyclical patterns. Research has even proposed that Betelgeuse's supernova might have already occurred, though moderate estimates predict that Betelgeuse's supernova event could be thousands of years away. Current evidence suggests otherwise. Scientists have proposed a model indicating that Betelgeuse may be in the late stages of carbon burning, making it a strong candidate for the next expected supernova event in our Milky Way galaxy. However, observing Betelgeuse is like solving a puzzle with conflicting observations. There are signs of material ejections and subsequent recovery, leaning toward a massive ejection event, although on a smaller scale compared to our Sun. Supernovae are real phenomena, as evidenced by the one observed in a satellite galaxy of the Milky Way in 1987. While estimates for Betelgeuse's explosion timing remain uncertain, it is not yet time to plan a vacation around it. The challenge lies in the difficulty of observing Betelgeuse despite having studied it for centuries and noting its brightness changes over time. There is insufficient evidence to predict exactly when a supernova might occur. A supernova is a brilliant explosion that happens when a star dies, and it is not harmful to life on Earth. The brightness of a supernova depends on the size of the star that explodes. Betelgeuse's supernova would be extremely bright, akin to the light of a half-moon, and visible during the daytime. However, the brightness of a supernova would also pose a challenge for astronomers, as the explosion could obscure the view of other stars and planets, making it difficult to study the night sky. One possibility is that Betelgeuse might have consumed a large object, such as another star, which could have accelerated its evolution and increased the likelihood of a supernova. A recent paper suggests that Betelgeuse's brightness cycles, particularly the longest period of 2,200 days, could be the key to its eruptions. If this is correct, the star's brightness could change significantly in the future. This remains speculative, and further research is needed to confirm it. Despite the potential challenges, the brightness of a supernova would be a mixed blessing. It would be a stunning and exhilarating event to witness, but could also complicate observations for astronomers. Betelgeuse's potential supernova offers a unique opportunity to capture its essence in remarkable detail. Unlike distant twinkling points of light, Betelgeuse reveals itself as a brilliant disk through telescopes, inviting us to observe its iridescent variations and appreciate the subtle dance of its light. The supernova display will not fade quickly. It will linger in our night sky for months, gradually fading like a distant star. There may be moments of renewed brightness before its light gently disperses. While the supernova poses no threat to us, it could surprise animals that navigate by the moon's glow, as the additional cosmic light might disrupt their nocturnal behaviors. Astronomers will face new challenges in studying the universe, as a blazing supernova will add complexity to observations during twilight periods. Nevertheless, the allure of this celestial event will attract countless telescopes and scientists, who will eagerly adjust their observations to capture the grandeur of Betelgeuse's final act. The anticipation among astronomers and stargazers is palpable as they await the magnificent and dramatic cosmic explosion of Betelgeuse. Earth is safe from harm as Betelgeuse is located at a comfortable distance. The explosion will not exceed the brightness of the moon or the sun, but will cast an ethereal glow, illuminating our nights and making its presence known during the day for an entire year. Imagine the captivating sight of Betelgeuse's brilliant remnants creating gentle shadows upon our world. This celestial display will unfold over several months, initially dazzling us with its brilliance before gradually fading into the night sky. There may be moments of renewed glow before the star disappears, leaving us with cherished memories of its celestial brilliance. Researchers have found that Betelgeuse's brightness cycles resemble those observed in stars approaching the end of their lives, suggesting that Betelgeuse could go supernova soon. If it does, it would be the closest supernova to Earth in hundreds of years. The explosion would be visible to the naked eye and spectacularly bright. However, this remains speculative, and more research is needed to confirm when Betelgeuse will go supernova. Even if it does, it is unlikely to be dangerous to Earth, as the star is about 500 to 150 light-years away.